lesson, the last note in chapter 5 is putting it all together. Variation, slope, and first differences. Okay, and that of course is our goal then before moving on, which actually the next thing we'll have is a test, but we're going to connect first differences, rate of change, slope, and constant variation, everything we've done. Okay, Charlie's a little concerned about this because now he's got to really look at a situation and use everything we've used this chapter, everything we've learned this chapter to figure it out. All right, so let's look at a relationship. And this relationship in this case is being shown to us by a graph. Now hopefully you can read your graph numbers better than I can on the screen, but everything's going up by ones. 1, 2, 3, 1, 2, 3. And it says, first thing is calculate the slope. Now think back to yourself, how do we calculate slope? Well, of course we do that using, in this case, rise over run. Okay? So we can actually just, take 2 data points on our line. We'll take that one. Always try to find ones that cross, like that cross nice and even so you get a more accurate number, that cross right on the grid point. Right? So this one touches nicely. That for sure is a data point. That would be 0 and -2. And then there's this one up here, which is, list the x first, which is 2 and 1. Okay? And to find the slope, okay, that's going to be rise over run. So I could take this and find the rise. And you can count the points, you can do whatever you want, but it goes up by 1, 2, 3. We have a rise of 3. All right, so I'm counting, up by 1, 2, 3. And my run down here is how far it moves across between those 2 points. And it goes across by 1, 2. Now, you can express the slope in different ways. You could divide 3 by 2, but often, as you've seen in math, we often like to keep a fraction. It's a more accurate way of representing it. So it's just going to be 3 by 2. So you could actually do the divide and find that it's 1.5, and that would be fine. But I'm going to leave it as a fraction. Okay? And, 3 over 2 is an exact number, but what if it wasn't? What if it was 7 over 6? Well, then if you calculate that, it would be infinite decimals. So again, it's better just to leave it like this. Then you have to ask how many decimals do I round to, all that. Okay, the vertical intercept. Well, that's b, right? And the y-intercept, again, is the y value where x is 0. So here, this line, this represents x equals 0. And on this graph, when x equals 0, y is -2. So b equals -2. So write an equation. Well, the equation is y equals mx plus b. Is 3 over 2 x, and it's minus, so I don't write a plus, I write a minus. -2. And that's my equation for the line. All right, next. Here it gives us the equation. It says make a table of values. Okay? Where x is between 0 and 4. So first thing I'll do then is write in, 0, 1, 2, 3, 4. And to fill in the table of values then, I say, well, y is -3 times x plus 2. So I'd go like this, -3 times 0, because that's x, plus 2 equals 2. Right? -3 times 0 is 0, plus 2 is 2. Then you go -3 times 1 plus 2 equals -3 plus 2 is -1. Same thing down here, just keep going. Minus 6 plus 2 is minus 4. Now this is going to be interesting because it looks like, and I guess it makes sense, it's a negative slope, negative 3x. So the numbers are getting more negative. So it kind of gives me an idea what my graph's going to look like. Minus 9 plus 2 is minus 7. And minus 3 times 4. Okay? And so that just shows me that the graph is going to look something like this. That's a negative slope because the numbers are getting more negative as the x's get more positive. And that says just draw a graph of this relation. So I guess I could start by putting a grid on here. And okay, and I'll make every box equal to 1 just to make it easy. So the first point on my graph then is x equals 0, y equals 2. So x equals 0, y equals 2 right here. I almost didn't make it on my graph. X equals 1, y equals negative 1. 1, negative 1. 2 and negative 4. 3 and negative 7. And 4 and negative 10. Now I made a bad graph there. It's not going to all fit. It's going to be down there. So I'm just going to leave. It's going to be a straight line, so it should work in all those points anyway. Then it says graph the relation. So I'm going to pick. Sure. And now I just got to join all those dots, right? From here to here. And really, this relation theoretically could go on forever. But there's my line. And because it could go on forever, I could draw arrows on either end, right? To show that this thing isn't just this set of data. It could be going forever. So I'll just draw an arrow there and draw an arrow there, and that just shows that my line, right, go off in all those directions, especially down there since I didn't get my last data point in. But that's my relation, okay? Because this doesn't say that it has to be stop and like it doesn't have to be. There's no reason to think this can't go on forever. Okay. So next, consider the relation represented by the following data. So now you're getting this idea that it could have, a relationship could look a lot of different ways. It could be a table of values, it could be a graph, it could be an equation. Oh, here we go. Consider relation. Determine the slope. Well, I would love to use my first differences to find the slope. But here's an example where I can't. X is going up by 2. I cannot use first differences to find the slope. Okay? This one. So I'm going to write that down here. I want to make a very big point. Cannot use first differences. Okay, because x goes up by 2's, I cannot use first differences. All right, so how am I going to do it? Well, you have to keep in mind that when you look at a table of values, you're really looking at, I'm looking at data points, right? So I have a data point, one of my data points is minus 3 and minus 0.5. And that really could be, my x1, y1. And I've got another data point, and I'll take the second one, and I'll say minus 1 and 0.5. Well, that could be my x2, y2. And just remember that, to find slope is change in y over change in x, right? Remember that triangle means change in y over change in x, which is equal to y2 minus y1 over x2 minus x1. So all I have to do is substitute in the numbers and calculate my slope. So it'll be, here's my y2, right, 0.5. And here's my y1. So that's minus 0.5, right? So I got to go minus minus over x2 minus x1, which would be minus 1, negative 3. So m equals minus, or 0.5 minus minus 0.5 is 1 over minus 1, basically plus 3, 2. So my slope is 1 over 2, or 0.5. Okay, so that's part A. Then it says to find my y-intercept. So this is a new skill, and this is fairly complicated, and I'm going to write down the strategy to find the y-intercept. Now, you know, it's different because now, you know, you can do it a few different ways. Like you could look at it and try to figure it out, because my y-intercept is going to follow when x equals 0. So in the recent note, I said, you know, you could just keep extending your table of values back, but here it's right in the middle, right? And so, I mean, I could make a guess. If it's going to be right, if 0 is right in between minus 1 and 1, then my y-intercept's got to be right in between those two. The proper way to do this is, let me write this down for you. Oopsie, that was a mistake. The proper way to find the y-intercept, the best way to do it, take the equation y equals mx plus b, which we know, right, is 0.5x, right? Or half x plus b. Okay? Because I say half x because we figured out m equals a half, right? M equals a half. Then sub in any point on the line, which could be, you know, this one or any of them. Just take any point on the line and sub in any point on the line to find where, to find b. Okay? So I'll show you what I mean. When I say sub in, I mean I'm going to sub in a y value and an x value. So here's an x value, here's a y value. I'm going to sub those into this equation and solve for b. Right? So you have to use your equation skills. This is why we had to do all that algebra to start the semester. Okay? So my data point I'm going to choose, I'm going to sub in x equals, I'm going to choose this one, minus 3, and y equals minus 0.5. So it has to be a data point where, you know, right off the table of values. So you look at the table of values, you pick any, it doesn't have to be the first, it could be any of them, but you sub any of them in to this equation and solve for b. So that means I'm going to write minus 0.5 equals, because instead of writing y, I'm writing minus 0.5 equals 1/2 minus 3 plus b. So you know from when we wrote equations that now we can solve for b. It's not a pretty equation because of the fraction, but it doesn't matter. There's different ways you can do it. You certainly learned how to deal with fractions last semester. But because this is a decimal, I'm going to make this a decimal anyways. So minus 0.5. Remember, 1/2 is just equal to 0.5. 0.5 times minus 3 plus b. And we're solving for b here, okay? And leave this minus 0.5. Okay, you can do it in your head or your calculator. 0.5 times minus 3 is minus 1.5. Okay? plus b. Now I'm going to add 1.5 to each side. To get b by itself. Okay? So minus 0.5 plus 1.5 is 1 equals b. Now I've got my b value. So it's hard. It's a lot of steps, but that's how you do it. Okay? So that was part B, was finding b. All right. Now let's find the equation for the line. Well, that's easy. So part C is finding the equation. Once you know m, so y equals 1/2, which is our m, x plus 1, because you add b. Okay? And last, describe it. Oh, describing it using words. I like this. How do you describe this relationship using words? What does that mean? Well, I'll tell you. I'm just going to get this so I can type it instead of print it. It's easier for me to type. So I'm going to describe this relationship using words. It tells me what this equation tells me. I look at it and I say, okay, well, this relationship starts at a y-intercept of 1, and it goes up by 1/2 with every value of x. So, and it's a positive slope, so I've got a positive slope I can say it's got a positive slope of 0.5 or 1/2. Same thing. And okay, something like that would describe it. Okay, this is a long video, so I'm going to stop, and there'll be there's another couple of examples that you'll have to watch after. This is after. So I'm going to stop this one just because it's getting so long, and I'll start a new one in a moment.